So I'm gonna wait until I see that we are live, and we are live. Let's see the title. Start compilation to our x86. Okay, so today is gonna be command line parsing for our Objective C VM, and that should be it. Okay,
We're recording now.
yeah.
Hello, future people.
Hello, future people. So today we decided to stop talking about compilation because, well, let's talk it about now. So what did we decide? We decided to do? So there is a way, answering the title of last session, there is a way to make it compilable to x86, but it's gonna take a little bit more finesse and a little bit more smart solutions, clever solutions, which Marinho does have. But we decided that if we ever gonna do that, we're gonna do it next time. So in the next milestone, whenever somebody decides to pick this project again, which are not that high, unfortunately. Not because people hate it, but because I think that uh, I have a really hard time visualizing somebody aside from me and Marinho doing that, and me on the driver's seat. So I think it's very unlikely. But the solution exists, and we're gonna say what is the solution. So Marinho proposed that if we divide the program into two memory sections, right? So ROM and RAM, and the program is only in the ROM memory, we would get around the problem that we discovered last time, which is programs that write within themselves.
Yeah,
Uh,
self-modifying code, all
Self-modifying
that
code,
fun
yes.
stuff.
So if you have a program only in ROM, that's 100. That seems very possible to compile to x86. You're gonna have to do some some abstractions to be able to have the data stack and the return stack. But that's fine. And then how do you cope with programs that do have stuff written in the RAM, right? So the main difference being RAM being writable memory. You basically link the assembly spit out code with a .so that we're gonna generate using the interpreter. So you're gonna externalize the interpreter, link it with the assembly, and when the assembly has RAM, detects that it has RAM to deal with, it's actually gonna call the interpreter. So it would be like a mix of compiled and interpreted in the output of the thing. And apparently Mario even
The
said that some implementations of Common Lisp actually exploit that.
Yes, some interpretations of common lists have historically done that, because part of the standard is that okay, you will have a function called compile that you pass a function to it and it compiles the function. And that implies that there are some functions that are not compiled that are interpreted. Uh, the standard does not mandate that you actually have interpreted functions, and in fact, SBCL it just compiles everything. Like there's no interpretation there. But the standard does allow there to be interpreted code and compiled code mixed together. So
Yeah, so
that's a thing.
that would be the solution. But Marinho decided that, in his opinion, we should do that in the next time. I would do it in this time, to be honest, because I think it would be a very interesting challenge to accomplish. Because it would be a very interesting problem, right? A very intricate problem because you have to deal with this whole interpretation and compile code together as the output of the compiled program. Uh, but I'm gonna follow Marinho's lead because this is mainly his project in the terms of the design of the thing. If he wants it to be next time, so let it be. Unfortunate, but okay. So
Yeah, now
then,
that you mentioned that, it's like Baguette was like, okay, let's do a VM. So he had the idea, and
yeah,
then I was the one mainly behind the design, and Lemos was the one driving. So it's like there's a bit of all three of us here. I think that's kind of cool, actually.
Yeah, no, that's fine. I'm just saying that again, I think it's an opportunity, but I'm gonna follow your lead. So if you think we should do something else, we're gonna do something else. Uh, so the something else that you're gonna do today is actually to fix a PR. So there is a PR open. There is a PR open in here. So pull requests, which is this PR. So this PR's purpose is to close this issue, which is that when you right now you were obligated to provide an input file which is written in Chime, and the issue wants it to be an option to be available that allows you to have a compiled program, and then you just run it. So you don't have to parse it actually, because if you think about it, Chime is already a hybrid, right? Because the parser is actually a compiler, because it's compiling keywords to words, and then we pick that and we throw it at an interpreter, and the interpreter reads the sequence of words and do something about it. So what this would do, this would basically allow to skip the parser completely. So if you have a file that you already saved from a previous thing, you should be able to load that, and you should be able to execute that as you may please. So I already made a PR about that 3 weeks ago. I did that in an offline session because at the time we were doing Racket Hour stuff at the same time that I was doing this, and it has some problems with it. And one of the problems that I think we can try to demonstrate it right now is, so let's see. So if I provide samples and I provide this and I provide .l, I think it's this one. Okay, so you cannot use, we need to adapt the gist file to fix this. So you need to do result bin chime boom. So it does work, right? It does work, but that should not work. And the reason it should not work is because if you take a look on the code that I wrote, if you don't pass a candidate program in a candidate dialect, it should just throw an exception at you, and that's not working at all. So I think one of the first things that we should do is to put an ns log here. Uh, so I think that's how it works, and then we can put candidate program, and then we can just build. So let's see what happens. Okay, so this is because I have to configure my flake more correctly. So I hope my news is still there.
Oh, I am. I am.
Okay. I'm fetching something here, 67. Okay, but we should take a look on this, Marinho. So, how do we check if something is new, though? That's what I don't really understand.
I think that what you have there should work, but it's just. Hmm.
So my understanding is that the NS mappable, if it returns something, we should actually check documentation. So NS map table Objective C. Okay. Um, can it return something? or new if no value is associated with a key. So it should return new, but it's not returning anything, so I have no idea why yet. We're gonna discover very, very shortly. So it is returning samples slash sum.chf. Oh yeah, that's correct actually. So in this case, we need to remove all of this. Yeah, so it is printing nothing. How does that work?
That is very weird.
So it's printing absolutely nothing. Okay, so let's how to check for new objective C. Yeah, that's kind of what we want. Oh, you can just do this, but it is saying that this is the same as this. So I don't know.
Yeah, it's yeah, the codes there should work. Like it should throw the exception, right? Which is not quite what we want anyways,
No,
but
it's
it's
not.
weird that it's
I agree. It's not what we want anyway. But
and
how
it's
can I
weird
say?
because you would have thought that this would have thrown an exception, but it doesn't.
Okay, but let's actually move things from here. Okay. So I don't remember anymore where the heck I'm doing this. I think I'm doing it in the main, I think. So let's go to main. So handle, yeah, let's remove the handle. And let's actually just call the things. Let's just call the things.
Oh, wait a second. Wait a second.
So I'm gonna put this here.
I think I see why. Because we are allocating a mutable string and then initializing it and then passing it to whatever, right?
Yeah.
But if we are allocating and initializing a mutable string, it shouldn't be new. It should be the empty string, right?
Wait, what?
Like we're allocating a mutable string and initializing it, and then
Yes.
passing it to the handle program and dialect, right?
Yes.
Well, in that case, it's obviously never going to be new because we are explicitly initializing a mutable string. It should be the empty string at most. It shouldn't be new, I think.
Ah. So let's look at the definition of the NS mutable string. Here. Declares the programmatic interface to an object that manages a mutable string, that is, a string whose contents can be edited. The concept represents an array of Unicode characters. To construct and manage an immutable string, blah blah blah, creating one. Oh, I think you're right. This needs to be at least empty. I see. So, but how do you retrieve? How do we retrieve the value out of it, though? Know what I mean?
Well,
How do you compare it? Are you just gonna do this?
maybe, but then what if string literals are never equal to mutable strings? Because that could be like there is actually a legitimate design choice to say, okay, mutable things are only equal to mutable things, and immutable things are only equal to immutable things. Like, I don't know if Objective C has that level of thoughts put into its equality semantics,
Oh,
but it could have.
release. So to make it new, You just release the memory, and now it becomes a null pointer. That makes sense.
Well, but wouldn't we need the data inside of the mutable string at some point? We can't just release it like whenever. I mean, technically we can, but that doesn't sound like something we actually want to do.
We want to check. That's the thing. This is a dynamic string, right? A mutable string. So it's a char star star. That means
There
that we.
should be some way to check if it's empty, no?
I don't see it in the NS mutable string. And I guess it makes sense. It's dynamic. So and apparently the dynamic implementation doesn't have like a capacity as you would do with a dynamic array in C. It doesn't have a capacity thing. So let's see. So length ns mutable string objective C. Count chars. Yeah, that's what we want. I wonder if the ns mutable string has all the stuff that the ns string does. Because if that's the case, we could simply just
Well,
do length on it and check if it's 0.
that makes sense actually. Yeah, we can try it out.
Okay. And you also, sir, wanted to be you want to not force the user to evaluate every time,
Yeah,
which is kind of
because
annoying.
yeah, because like the way the main function is currently written, it's always going to execute the code, right?
It's always
Even
gonna
if we
execute
may
the code,
just
yes.
even if we may just want to compile it.
Yeah, that's very true. Uh, but I mean, uh, that's fine, I guess. But I'm thinking, what is the best way to do this? Because remember, people, this is like C, so we don't have quality of life things such as I don't know. I don't remember the name of the crate in Rust that does this beautifully, and we also don't have the command line package in Haskell. So we have to do things by hand, and it's a pain in the fucking butt.
Yeah.
There. Okay, so let's see if this works though. So let's go to main. So let me read it for you what's happening. So we initialize the candidate program and the candidate dialect. We see if they exist in the map table. Then we check if we ask for loading. Because if you ask for loading, we don't need those two. Um, okay. So these we are checking if it's different than you, because if it is, we don't need them. Otherwise, we're gonna check if we have the two things, and then we're gonna load our program. And for now, we are still evaluating, but we're gonna handle this later. Let's see if this breaks now. So this should not break at all. This should just work. It works. Now, let's do this. Expect the file path of a program as the first argument in the command line. Samples, sum. Expect the file path of a dialect as the second argument in the command line. And it works. And if you pass
And it
both
works.
of them, if we pass freaking both of them, it's gonna ignore yes. And we also should be able to save them. So if we do this, that's cool. And if we do ILS, we do have test2 in there, and then we can just put test2 in here, and it just works. Now
Now
though,
we just need to make it not run when we want to save, yeah.
yeah, we need to make this line here something. So how the heck we're gonna do that? So let me explain how I am currently doing that, which is terrible. Uh, so the way that I'm doing that, I am iterating through all the arguments, starting from one because we're jumping the program, of course, and then we're checking if we got a load thing or a save thing. Okay. Otherwise, we are gonna check if you already acquired the program and the dialect. That basically means that you have the freedom of doing stuff like this. You can do that. But the order does matter. So the first thing that is not in a couple, so this is in a is coupled, and these are also coupled. That means that they walk together. This is the first one will always be the program, and the second one will always be the other thing. If we want to make it a little bit like more consistent, we could do like this and like this. What do you think, Marin?
Uh, yeah, I guess we can do that. I don't see why not.
That will make it so much more simpler. Because why, you may ask? Simple. Because I had to do all these extra checks to know, have I read the program, the file path already, and stuff like that, and all that nonsense.
Yeah,
So
it's easier if you either always do positional or always do keywords. Mixing the two is like more work.
yeah. So what we're gonna do? We're gonna do P or program. Uh, and the error that we're gonna have uh, is missing. Where is it? Not load. Oh, I don't have it in here actually. Let me grab it. So these are the functions. So the first one is missing program file path. This can go, and these I'm gonna save for later. And the key that we are looking for is program file path. And that should be it. Um, and the pattern is starting to emerge here, so we're probably gonna be able to extract this to a function. Uh, and then the dialect. And if you have a problem, you're gonna do that. And then else, it's gonna be the extra arguments, whatever, whatever. Yeah, it's gonna be this. There. And you can get rid of all of this, I believe. Yep. Oops, 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 oops. Let me first remove this. So dialect, file path. So can we get rid of this? Yes. Awesome. Then I can also remove this boolean that serves no purpose at all. Amazing. Amazing. So now, Marin, how can we extract this operation? Because you see what we are doing here, right?
Right. Right.
We are doing it multiple, multiple times. Actually, that's a good question. Uh, how to pass a function as parameter? Method as parameters. That's even cooler. Uh, the type that you're looking for. Wait, what? How do you pass one method as a parameter to another method? I'm doing this across classes. Run the func here. Oh, he wants a high order function. Look at the C people, they are growing, bro. The type you're looking for is a selector, and you get a method selector like this. What? If the method takes parameters, you just put column where they go like this. I don't understand.
Because the method names are actually segmented, right? But
Yeah, no, yeah, but how does that answer the question?
no, you just say, okay, selector of whatever, apparently.
No, but here is very clear. You have a you have a class A, you have a class A, and you want to call the the big function. This method expects another method to come. How is it doing it in here? You can call that method on your target like this. Perform selector. So,
What an opaque name for a function call.
but they do have Objective C makes this operation relatively easy. Apple provides this documentation. To directly address your question, you're not calling a function but a selector. Here's some sample code. Ah, I see. So they did think of that. You
You can
can.
use blocks for this purpose.
I think I saw what this. I think I saw this before. Yeah, I think this is how you make like closures of sorts.
Of sorts.
Oh yeah, look. Key sort B. Then you pass the characters, you pass the size of them, and then you pass how you sort them. Huh? Come on. They have closures, bro.
Yep.
Okay. Okay, but again, it's a very interesting that they had this all the way back and Java didn't take a bunch of it. How sad. So they had high order functions, which okay, they didn't bother to make the C functions high order, but they bothered to make the methods high order. And they also have blocks so they can have closures.
Well, they can't really make C functions higher order, at least not more than they already are, because then they wouldn't be C functions anymore, right?
No, I think they should still use like the void star stuff, but they should have like a syntax sugar of sorts, bro. In like to make C functions behave a little bit more powerful.
Hmm.
It would be very nice. But maybe they were following strictly the philosophy of if we want to make C better, we're gonna rely on our abstractions. We're not gonna touch on the to make the retrocompatibility more complicated. Maybe they wanted to make these things orthogonal. And why am I talking about higher order functions? Because we can't pass a function. That means that this, well, if you don't want to use a void star, we cannot parameterize this, which would be very nice.
Right.
Because we would just do argv, const char argv brackets to that. We're gonna pass the position I plus one and the function and the name of the key. Everything else is gonna be external. But okay, so what's the best way to do this then? This is mutable. The I++ is mutable. So it is locked in this for loop context. So we would have to like mutate it from somewhere else, like pass a pointer. Ah, amazing. And we can pass a function to this.
In this context, actually, I think we can just use a function pointer, right?
Why not a macro?
Because a macro means you are now dealing with um, you're now dealing with string substitution in a place where before you weren't.
But isn't C macros just like replacing tokens, a series of tokens? Because this piece of code
No, no,
here,
no, no, no.
couldn't I
No,
just
C
extract
macros.
this out
Oh, you could. Um,
and just replace
you
this and
could.
this?
Yeah, you could. The problem is that C macros don't actually replace a sequence of tokens. They replace strings, actually, with no regards to the lexical structure of C whatsoever.
No, no, I understand that the lexical scope would be kind of meh because where's the I coming from? Where's the CMDs
No, no, no.
coming
I'm not
from?
talking about scoping. I'm talking about the lexical structure.
Ah, okay. Could you elaborate on that?
Like you could have a C macro that when you expand it, it literally just becomes a close curly brace. And that's valid.
Sure.
Do you not see the problem there?
No, no, no. I see the problem there, but I'm saying that because it's only these lines, I think it would be less terrible to have this boilerplate.
Yeah, in this case it's probably fair. It's probably fair.
Okay, so C
It's
macros.
it's not ideal, but then again, nothing in C land is ever ideal, so we can just do it, I guess.
Hilarious. So I don't
It's the
remember
truth
at
though.
all. So. There are some, like for instance, if you're always gonna do things in pairs, I think this is fine. Like we are just trying to remove some boilerplate, and that's why I'm fine with a macro. So we could make like save arg, and then you pick the key, you put the key name, and you also put the error message func, and then what you're gonna return. Oh, there's no indentation. Cool. Is I don't remember. Is you need to do this?
I think you do it, yeah.
So where
You might.
is?
I'm not sure.
Okay, let's actually just grab it and put it in here and make it inline. Why not? So in here we're gonna do error message func parentheses.
You should put parentheses around the error message func.
I should put parentheses in the error message func, like oops, like this.
Yeah.
Okay. Then we're gonna do that. Yeah, I think it's at least fair to put it in here. Uh, and you're gonna do this. So I want the quotes, but how do I deal with the key name thing? Do do
Um,
I just put this? Do I just do this?
I think you can put the quotes around the key name. I think.
Oh, it's like this.
Yeah, we can try that out, and if it doesn't work, we can just change it.
Okay, let's replace this guy. So save arg, and we're gonna put save in the file path, and the error message is load file path, and that's this, right?
Right.
So then we can get rid of this. I'm gonna be 1,000% surprised if this works. Of course it doesn't.
Of course it doesn't.
So we only can see the warnings. Okay. So expected, do we need to put there? Oops. Wait, where is the example of the macros? No, you don't need to put. Uh, okay, so for the sake of the argument, I'm gonna put in here. Okay, it's still failing miserably. There, there. Expected blah 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 after expression. What do you mean, partner? Do you understand what is asking for?
Not quite.
Because it is saying expected that after expression. Am I doing things alright? How do you do? Oh, it's with comma. It is with comma. Is it because we have a space in here?
It might be.
No, it is not because of that. What are we doing wrong?
I don't know.
You don't know. Okay, what if we put the thing in here?
Then you probably need to change the macro to like not, you know, not call the thing that's coming out as a result of that.
Like this?
Yeah, sure, we can try that out. And if it breaks, we change it.
Okay.
Wow, what? Okay.
Expected the file path of a program as the first argument in command line. So that means that it didn't work. I think I'm correct on that. So let's put ns log. This is a test. Oh, no, it did. It entered here, but it didn't work at all. Amusing.
Hmm, okay.
So I'm starting to guess that we have a little bit of a like. Is it because of these double quotes? Oh yeah. Okay.
Huh, okay.
Okay. But now it's that much cleaner.
Oh, it's because it's because you passed the load file path with double quotes to the
Yeah, that's
macro.
that's why I always think it is a sequence of tokens. It is precisely because of that.
But I mean, you could have removed the quotes from the macro argument, I think.
And then we can remove this. If we could, I don't know if we can. Can we put this inside a function?
Uh, Maybe. I think you can actually, but it's kind of cursed because it looks
It's
like it
kinda
should be
cursed.
local to the no, because it looks like it should be local to the function, but it's actually global.
I mean, you're not wrong. But at least reading it, the intention is more clear to me. So what is the problem with this one? So it's Okay, this is not so bad. Come on, that's not bad. We are getting there. We are getting there. So now the question is, expected the file path of a program in command line.
As in,
Uh, actually, uh, alongside the flag, so then we can do that. And also, why does it have with format? That doesn't make sense. File path of a program. Whoops. Okay, maybe we should also say the flag, I guess. So, or I think that's fine. Cool. Cool. Okay, now, sir, we have a problem.
okay,
How the heck are we gonna add a flag to force evaluation? Or do you want a flag to remove evaluation?
like in case you want to both compile and execute a program, is that it?
No, because you said that what if I just want to save a program? I don't want to run it.
Well, if the save flag is set, then we just save it, otherwise we run it.
Oh, so that's much easier. Thank you, sir. I appreciate that. So it's not possible to save it and run it.
I mean, like you could always just save it and then run it as a separate command. So I don't see what the loss is there.
Well, because maybe in a single command line I would like to run it and save it. That's why.
And to just use a semicolon for that. I'm pretty sure that's what the semicolon is for.
What do you mean?
Like in the shell, you can use a semicolon to have like two things in the same line.
Oh, you mean running the program twice?
I mean, you could like add a way to both compile and run the program in the same invocation of Chime. But like, I don't see that as a common use case.
The quality of life is getting a little bit worse in my opinion, but I guess that's okay. Let's test it. So this is if you want to load it. So if I pass up this, I don't know, something, and I pass this else, and I ask it to run it, nothing's gonna happen. That's fine. If I remove the loading though, that should not happen.
Wow.
uh, that should not happen at all. So we need to go to the VM. And the parser is not complaining that we provided nonsense to it. Okay, so parse program. We have a file path and a keywords path. So this is not throwing up, surprisingly.
Huh.
So let's add like, I don't know, whatever, and exit one. Am I doing crap? I am doing crap. It's new. Why this is not doing its thing? What? Oh, because it's a pointer. Is that how that works?
But new is supposed to be a pointer as well, right?
Wait, what? We ran out
Like
of
new
memory.
and new are supposed to be the same thing, right?
I have no idea. So let's check this. Check new pointer. That's not really what we want, but that's fine. They have something called ns new. What is the name?
Why
Okay,
are there so many ways to say no in Objective-C?
I'm counting two. What are the other ones you're counting?
Okay, you have no, like the C no, you have nil, you have ns no apparently.
Oh yeah, okay, so that's quite a bit. That's three. Init with contents of file.
And I suppose if you count zero, that's a fourth one.
A data object initialized by reading to the data from the specified. The method is equivalent to this with no options. So this returns a pointer. No, this returns a data object. This returns a data object. Huh. How do you check for null? How to check ns data for null? Ns data null check. When you use an equal equal operator, you're comparing pointer values. This will only work when the objects are comparing exactly the same object at the same memory address. You can also use is equal to data method. This method return yes if the contents of data are equal to the contents of the receivers, otherwise no. Two data objects are equal if they hold the same number of bytes and if the bytes are the same position in the object are the same. So if you have an NS data and you compare. Okay, so this is just explaining the problem. Ooh. So
What?
if you fail, they don't reserve the failing to C. They also want that to be handled by Objective-C. No, it's still wrong. Oh no, of course. No, didn't work at all. Uh, what? What am I doing wrong here?
Mm,
It is going to infinity, even though I'm putting return 1 in there. Do I need to put return new? What? I'm
how
extremely
weird.
confused. Oh wait, I want to check if this is true in this case though. That didn't work at all. So error handling programming guide. I'm getting data from server. NS data is good and gives a number in bytes. The NS string is null. What's wrong? Yeah, this is just teaching the person how to do stuff. Okay. Error objects. Okay, we know that already. And that's not helpful. Yeah, so I think our best bet is here. But that's really weird. That's so weird though. That's weird, bro. Nothing worked in my case besides this. Oh, wait a moment. This is data image and this is V. What the heck is V?
Mm.
I'm using. So we don't know what V is. I thought it was supposed to be the data. Can I type null? No. Hmm. Okay, so I guess we already tried data equals null, right? We already tried that. Doesn't work. We already tried new. Doesn't work. So, and if I put
Um,
return 1 in here, it does work. Very bizarre. So now my
what are
question,
you
go.
Wait, what are you passing as a dialect? You're not passing, you're passing it nonsense, basically, right?
Yeah. So this is a non-valid file path, and this is what this error is here for.
Mm.
So I want to see, is NS data like is there a null checker? So creating data, reading from data, writing to a file, accessing underlying bytes, finding data, testing data. No, there is not a single way to check if it's null. So ns checking for null. New null mass. Uh, that sounds bad. Okay, so they improved that on Swift. That's very interesting to know. New being the terminator to variadic functions will cause the input to stop being considered the moment new is found.
What?
So they use new as like a frontier, like a bound thing.
A sentinel.
Basically, yeah. So it's like zero string termination, but in asteroids, I guess.
What happens if you want to have an array that can contain strings and no values? Oh no.
If nu is the essence of nothingness, then as nu is the representation of it. And as nu
Oh
contains a method
no.
nu, whose only purpose is to give you a singleton to a representation.
Oh
There are
no.
many times when its pure purpose is not wanted. So we can ask our question: can we have an array of objects that also has null values? The answer is yes and no.
Oh
NS_NU is an
no.
actual foundation object. It inherits from NS object like anything else. We cannot have an array with pure new or pure nothingness.
Oh
What you need
no.
to do is to replace it with something foundation can understand. You can think of
Oh
NS_NU as a
no.
wrapper, but I prefer to think as a dummy that represents nothingness in the same family as NS object. Um, then we have that. Okay, there's something about JSON that we don't really care. Okay, okay, this is interesting. So if you read up until now, you may deduce that null is printed with different parentheses or angle brackets depending on whether it's new or ns null. But which is which? The console will print with parentheses when printing real nothingness and null
Oh
when printing
no.
with ns null. In other words, this is new, whereas
Oh
dictionary blah blah blah
no.
is ns null. In short, when a dictionary does not contain a given key, it will point to new. When the data does not have the key, but said key is null, it will be NS null.
Oh
So it's
no.
basically the opposite recommendation of closure, right? That you should never have in a map. Uh,
Yeah,
uh,
Clojure should really just have gone the Lua route of saying, okay, if you try to add new to a key in a map, that means you are removing the key.
yeah, but this is embracing the total opposite. That's the conclusion, basically.
Oh no.
Uh,
This is terrible language design. Why did they do this?
if you really think about it, this is the primitive maybe then. Because this is sending you the same amount of information that a nothing or a none would.
But you can just use new. Why not just use new?
Oh, you're saying that they should not have two things for. Well, the argument appears to be that they have two things for two different situations. If you don't have something, it will point to new. But if you do and the value is nothing, it would be this. And because you can mutate it, like this is feeling like a primitive maybe. I don't understand the benefit of separating from new though. Does this guy have methods?
It does. It has a no method.
No, 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 aside from that one. Oh, it only has that one. Returns a singleton. Oh, the fact that it's singleton is worse. It makes it all way worse.
Why? It's literally just a constant.
Yeah, but that's bad because two maybes are not the same. But this one will always give you a single one. No.
Wow, two maybes are the same if they have the same parameter, like the same type parameter, right?
No, a just two is not the same as a just three.
No, I mean, a nothing is the same as a nothing if they are of the same type, right?
No, yeah. But in this case, we are like part of the usefulness of having that parametric you don't have in here because, well, you don't have that. It's just an S null. But what is the benefit of treating them in two different ways? What could possibly be the good side of that?
They made a mistake and then they put a band-aid on the mistake and called it a day. That's the short version of
But you were
this.
assuming that making the band-aid is easier. What about this is easier than just using this?
The problem is that when they made variadic parameters, they decided, okay, let's do it using Sentinel instead of doing a count of arguments. And the Sentinel is new. But what if I actually want new as one of the values? So they made them as null as a band-aid for
I
that.
see what you're talking about. So it seems that the desire to have new as an option, it was an afterthought. So they made the entirety of the thing based on a sentinel-based delimiter. And
Yeah.
then later on, they said, wait a moment, what if we want this? So instead of rewriting, like basically crushing, like deleting the sentinel semantics, they decided to keep it, but to add something else. Oh, yeah, that's bad. I don't know how much work that would be, though. Maybe we're talking about a lot of work.
It may not even be about the work, it may just be about not breaking backwards compatibility.
No, yeah, I understand that. Wait, but what he said is, but then we are still not fulfilled because he said that when a dictionary does not have a given key, it will point to new. But we
Yeah,
are already checked for that.
but we are not checking for NS null. We only checked for new.
No, but this is the case. Our case is not that we have a null as a value for a key. Our case is the opposite. We don't have it, right? That's my
Hmm.
understanding. Actually, I don't know, right? Because this is not checking in a dictionary. This is just trying to read from a file that should not exist. So maybe we should check for NS null. But how do you compare it?
Maybe this is the same problem with the string case where we have an NS data, right, that we're allocating and then trying to initialize. Maybe it's just giving us an empty data instead of a new.
How do you check for an empty data?
I have no clue. Count? Does it have a count or a length or size or
Check
whatever?
empty. Yes. Oh, here, look. It is saying that it is not equals to new. Cool. Yeah, it has length,
It has length. We need to
apparently.
check if the length is 0 then.
Oh, it's actually a property. So empty 0.
No, it's not length, right?
Oh, sorry, I'm getting tired. No, didn't fix it at all.
What the heck?
I'm still confused because I can't return new. You see? I'm starting to think that I
Hmm.
can't return new, bro.
Why?
I have no idea. Could not read something. Program file. So how do I need to throw an exception? Are you guys just boy oh boy, you guys are playing with my heart. Throw. Oops. Throw. So I guess we don't have a choice. We need to break the program from the inside. Could not load file. Could not find file. Okay, but we discovered something. We definitely discovered something.
Hmm.
So the way that they decided to do that, it really seems like an afterthought, doesn't it?
Yes, it does.
Load Chime. That's fascinating, bro. So that's the trouble that you have when you don't think it thoroughly. So you make a decision.
Yeah,
You make a decision, and then later on you may regret that.
essentially, yes.
Fascinating. So where the heck is the dialect? Uh, where is the keywords path? We're grabbing file path, that's fine. And we are creating this. Oh, we have load keywords. Okay, so load keywords. So load keywords, yeah, there. And we're gonna put exactly the same. But instead of a program, dialect. So is this working? Of course not. So what do you want from me?
Mm,
Specify char, but you want, but the argument has a type ns string. So that means that I should use a here. Uh, oops. Of course not. Why would it? What?
passing. Hmm.
Format specifies double, but the argument has type ns string. What? And there's somebody complaining 362. 362 is here. And it is
File path should
complaining. Oh,
be
with capital P in here for some random reason. I'm actually gonna change this. But it is still complaining about the other thing. So, should we do this instead? Because it's an object and all that crap?
maybe, probably actually.
Yeah, but then do we need the at?
We do because that's what makes it an object.
No, but it's already an object. It,
Oh, in that case, probably not.
oh no, in this case it isn't. In this particular case it isn't. So let's see. But the other ones they may be. No. And no, I lied. Cool. Ah, fuck. What else do you want from me now? It is still complaining about 380. What the fuck? Oh, okay. That, yeah, that should be okay. Could not file, could not load Chime program. Reason, could not find file something. Okay, so samples. I think this is yes. Could not load Chime dialect. Reason, could not find file else. I'm satisfied with that.
That works, yeah.
Um, awesome. What else do we need to test? We need to test if we can load it. So yeah. We also should test if we can load and save it. Okay. We should
Okay.
also um, we should also attempt to pass a program, a dialect, um, and then save it. And this should
Test
be
for.
test 4. We didn't run it. That's fine. And if I
And then
ask
we have,
to not save it, it does stuff.
and if you load test 4, it should run it as well. There we go.
And if you pass
Nice.
something and else, it should not do not anything at all. Yeah. Oh boy. Okay. So okay, so there is an extra. I don't know if I want to do that. So there is an extra check that we could do, such as to see if a program terminates with .chf.
Uh, I mean, technically text files don't have to have any particular extension in Unix, so I don't know.
That's I don't know. I have no idea. We gotta pick a side, friend.
I say don't.
Okay.
Nay,
Okay then. We made it.
we made it.
We made it. It is with quotes. That's awesome. So is it good enough now? What do you think? So let's go step by step here.
Um,
So the first thing that we do is to parse things from the command line to create a map table. Then we check if we got the program and the dialect, the candidates for those. Then we check the candidate for the loading. If we load, we don't do anything with the other pieces. If we don't load, we check them if we load them correctly, and then we try to parse it and all that stuff, and to load the program. And then we check
okay.
if we somebody asks to save it. If we ask to save it, we're only gonna save it, and if we don't want to ask to save it, we're gonna run it. So that's how that
Okay,
works.
that makes sense, I think.
And then this is how we parse the command line. So it's basically like, or you have a short version and a long version, and then you pass the error message thingy, um, and that's pretty much it.
Hey, I think that's good actually.
Yeah, no, the macro really shrink this down.
Yeah, this is better. This is definitely better.
Yeah, I agree that is like really not safe, but the fact that okay, I know this is global, but the fact that we are putting in here is on purpose for the person to know that this is only being used in here, and this is just to make it nice to read. There's nothing really outstanding going on and stuff like that. So
Yeah, I think it's fine. Again, it's not ideal, but things in C lanes are very rarely ideal, so
Yeah,
I think it's fine.
I think it's
It's
very fine.
fine.
Then we have the error message exceptions that I made them functions because this is too long. Um, then that's it actually about this PR.
Yeah, I think it is. It really
So
is.
let's now update the README. So in terms of stuff,
Oh, we don't have closures. We do have function calls though.
so let's so we're gonna say that this is Chime 1.0 and this is gonna be Chime 2.0. So the first thing, well, I don't know about being the first, but we have this. We also should have. This is actually easier than the other ones.
Read-only memory and compilation,
Uh,
definitely.
ROM x86 compilation. So a runtime at your service. Chime is a hybrid VM virtual machine that first compiles a Chime program into a sequence of words, 32 bits each, and later on, and we should also add in here syscalls, and later on
Interprets.
interprets it. Uh, it is true incomplete. Uh, it is true incomplete. As for nice to have, you have uh, compile time literals, integers, and strings.
Yeah, I think we're pretty good actually. Like this was a good series of stuff that we did.
I still
And
think
next,
we are pulling the cord a little bit earlier, but that's fine.
no. Remember our original milestone. We still have next week where we will do the automaton, right?
Yeah,
The what is it? 110 game is
yeah,
what it's called.
yeah. So yeah, so let me put this on screen because we are recording. So not we it's actually so rule 110 this. So this is the outcome.
Yeah, it's basically it's kind of like Conway's Game of Life, except it's one dimensional instead of two dimensional.
Yeah. So we're gonna read it, we're gonna implement it, and we now that we have syscalls, we can print stuff to the console. I think it's gonna be really, really terrible because these are basically gonna be strings of characters, but we don't have operations to concatenate strings. So we're gonna have to figure
Uh,
that
do
out.
we do we need them though?
Yeah, actually. And now that I think about it, we need it more than I think because how are you gonna do new lines, bro? We don't have escape sequences.
Uh, no, 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 no. Hear me out. Hear me out. We say, okay, let's not do infinite. Let's not do an infinitely sized automaton because like we don't have infinite memory. And then if that's the case, we just have to statically allocate two strings, okay? And we basically do how programs tend to output video, right? You write to one string and then you print that, and then use that string as the input and write to the other one, and then you print that, and you kind of alternate between them, right? One string always contains the previous state, and the other string will contain the next state. And then after you print the next state, you just flip the two strings. And now the next becomes the previous, and the previous becomes the new next. And we just, keep doing that.
Okay.
And for the new lines, we can just cheat and actually use integers as,
Yes.
as we can just have an actual pair of integer literals like a one and the whatever number the new line turns out to be when you shift it up.
Well, we're gonna figure that out. I'm too tired to understand everything. So a runtime at your
Okay.
service, Chime is in a hybrid virtual machine that first compiles a Chime program into a sequence of words and later on interprets it. It is a Turing complete. It's nice to have. You have compile time literals, string support, and syscalls. Write and read from
Standard IO.
std out. So as features, we have stack manipulations for control, arithmetic and logic, address management, neutral instructions, function calls, strings, syscalls, uh, and we're gonna have implemented as the top example of its Turing completeness, I guess, the automaton. And for 2.0, whenever that happens, we're gonna do translator between dialects, which is the simplest thing out of like it's simpler than strings, and we didn't do it. Then we have closures, and then we have the two things that I think we should still do in 1.0, but I am the minority here, so ROM and x86 compilation.
Wow, I'm more than one person. I didn't know that.
No, I think my Geta would also agree.
Yeah, the thing about translator between dialects is that we currently only have one, and like
Man,
all
that's
the
the
examples are
easiest
written
thing
in.
ever. Just ask ChatGPT to generate 32 emojis with separated by new lines.
Wow. Okay. But like, okay, the translator is probably not even that difficult because the literals are all the same, right? You just have to, it's actually, you just have to compile it and then you have to implement a decompiler effectively that reads each word and, oh, I see.
No, man, it's easy. It's really, really easy. You just need to do a reverse map. That's it. So instead of picking a keyword and transforming that to an instruction, you grab the instruction, consult which name it was supposed to be in the original code, check its position in the file, and grab the same position of the new file. And that's it, done.
Yeah, yeah, no need to involve the compiler. That's probably easier.
Uh, so it's
A
a
decompiler would still be cool though.
no, it's kind of like it is kind of decompiling in a sense because we are doing the reverse of the current pipeline. We grab keywords, transform them to words, and the words we have instructions. We are doing the opposite. We have instructions. We're gonna skip the word representation, go to the dialect, and then with the dialect grab its position from the file and use that as an index to the new file. So it's kind of like it's related to decompiling, I guess. I don't know much about decompiling, but it sounds close.
Yeah, decompiling in this case would be okay, you have a compiled program, you look at the first instruction, and then uh, you transform it into a sequence of instructions, like based on a dialect. Like you take the word, you break it up into opcodes, and then you just print those opcodes, and then you print a new line, and then you do the next thing. You do the same for the next word, and you keep going. The problem with decompiling like this is that it's not quite obvious which parts of the code are supposed to be instructions and which are supposed to be literals.
Oh yeah.
I guess the easiest thing is that if a word contains an invalid instruction, which I think there's only one opcode that we didn't use yet, then that's obviously a literal. But you still have to decide if it's a string literal or a numeric literal. So
Oh yeah, we're gonna have to suffer with that, right?
yeah,
Oh no, wait, not really, actually, because we can leverage the instruction separator, the instruction extraction. So we don't need to care. The extractor will tell us this is instruction X.
yeah,
So it's gonna get around all the strings and all that nonsense. Uh, okay, cool. So just format. Nice. Um, let's add. Oh, let's first remove. We didn't touch that file, so I'm gonna remove it. And then git add chime, and then we'll commit saying so add review comments because Marinho commented all that stuff. And then I'm gonna add the readme with update readme. Okay, so resolve and resolve.
cool, very cool.
And we do have some conflicts, according to master apparently, which is kind of funny. So let me take a look on those conflicts. Um, oh, I made this before we had the strings. Okay. Uh, so I gotta remove those. I gotta remove those. So markers
I
resolved.
see.
Oh, this is a bigger diff. And everything else should stay just as it is. I'm not gonna touch it, and I'm fine. Markers resolved, commit merge. So let's see the changes now. Yep, yep, yep. You should also be different. You should be very much different as well. Different as well in the readme. Okay, bro. So I guess we did what we set out to do today. We discussed in the beginning that was unrecorded, but we discussed in the beginning if we will do or not the x86 compilation this time around. Then we implemented the extra feature of being able to save a program. As I expected, we finished it today because well, that was mostly already done.
Da-da-da.
And we have a goal for next week, which is to implement the automaton. And at some point in time, Maybe. Uh, Actually, not maybe. Can you see yourself implementing this after?
The rule 110
No, no, no.
or
The
the
x86 ROM stuff.
x86 run stuff. Yeah, I definitely want to give it a try, just not right now. I'd rather do another project.
No, no, no. Yeah, but you understand that in Zig you're gonna do something completely different because you have compile time macros, right?
Uh, yeah, actually, in Zig, I can just punch and not compile to x86 directly. That's one option.
No, yeah, and
Uh,
that's most likely what you're going to do because I know
Most
you.
likely, yeah, yeah.
So, ladies and gentlemen, he will do is the following. He will change the target of the. How do you explain that? You're gonna change the target of the binary to
No,
be.
no. What I'm gonna do is the following. I'll have a build option where at compile time I pass the program source and the dialect. I compile the program source at compile time into a binary, right? The same as we just implemented today. But then instead of spitting it out, um, I embed the binary into the interpreter, and I just compile the interpreter with the source code pre-compiled. You see?
Yeah. So function declaration is not allowed. What? I don't understand. Something is wrong. Let me remove my screen for a sec. Okay, because I'm gonna open Emacs. And when I open Emacs, maybe there's something in there. So I want to go to utilities.h, yeah. So my screen is now back. So look at this. So pad words, which is in fact in here. So backwards. Um, what? Oh, so the formatter did the if not inline. Thank you, formatter. Uh, Wait, what? We're missing a thing.
Huh. Okay.
That was bizarre, but wow. I can make mistakes. Yeah. Um, so uh, fix merge issue. I'm gonna push that. It's pushed. Um, it's still approved. Nice. Do we have any other? Yeah, we have another pull request. Oh, the geeks thing.
Yeah, I still have to figure out the whole linking thing. It's kind of minor, but it's annoying, so I kind of been putting it off.
Okay, so but we are trying to establish like a commitment in here. At some point, maybe 2024, maybe 2025, we will implement the mix of compilation and interpretation. All right? Is that all right?
Yes, yes. Whenever we get back to this project, that's the next milestone, and that's what we're gonna do.
No, 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 no. I want you to say exactly what I said because I can see you trying to pull a smart guy move on me and just trying to replace it with the Zig version.
Okay, we will do it. At some point, maybe later this year, maybe next year. Don't know how the projects go, but we will do it. Objective-C compilation to x86, uh, kind of the hybrid thing that needs to be done so that, well, compilation plays well with the language semantics. But yeah, we're gonna give it a shot because this is a Actually, a pretty interesting problem.
Yeah, it is a very interesting problem. Okay, I am satisfied. I didn't have to blackmail anybody. I'm very happy about that. So I'm gonna merge the thing. It's merged.
The next week is the milestone, Rule 1110.
No, it's rule 110 or 110. 110.
110. Yeah, I messed that up. Sorry.
That's fine. Okay,
Rule
so
110.
that's the.
Yeah.
I'm gonna finish the recording now. So, and